In this video, we are going to talk about finding the volume of a cube. And to find the volume of a cube, it is first important to understand what exactly a cube is. So the basic definition of a cube is that it has 6 faces, 8 corners or vertices, and 12 edges. But I want you to think of a cube like a box. And an important thing about this box is that each of the side lengths of the box are equal. So here I can draw a line here. This side length here is going to be S, and that's not perfect, but and then this here is S, and then this height here is also S. Keep in mind this looks shorter because it's based off the perspective of the cube, right? We're looking at the front of it, so this looks shorter. But it is important to understand that this cube has all equal side lengths. And now to find the volume of this cube, what we are going to do is find the area of one of the faces and then multiply it by the height. And you'll notice that when we do this, right, so when we find the area of this face here, this is going to be S times S, which we can just write as S squared, right? That's the same thing as S times S. And then we're going to multiply it by the height, which is S. And you'll notice if we broke this up into S times S times S, this is just going to give us S to the third power. So our formula to find the volume of a cube is just S to the third power. And this is actually why we say S cubed, right? Because we are taking S and then multiplying it by itself 3 times, which finds the volume of this cube. So third power is cubed. And now let's do a practice problem to find the volume of this cube. So you'll recall the formula to find the volume of this cube is going to be the side lengths to the third power, or side lengths cubed. And here we can notice that these side lengths are each 3 inches long. So what we're going to do, right, is we are going to raise 3 inches to the third power. 3 inches to the third power. And here we can just distribute this exponent, right? So this is going to be 3 to the third power, which is 3 times 3 times 3. And 3 times 3 is 9. And then 9 times 3 is 27. 27. But we still have this inches here, so we're going to raise this inches actually here to the third power. So this is a unique way to think about dimensional analysis, right? Thinking about what exponent does my unit of length need to be. And this is going to be to the third power because we are finding the volume. We are finding the volume. Let's do one more example like this. So let's just raise one of these side lengths to the third power. So here we have 10 feet to the third power. And this is going to give us, let's see, 10 times 10 is 100, and then times 10 is going to be 1,000. So that is 1,000. And then we can raise this feet here to the third power, or just notice that we're talking in volume, which takes up 3 dimensions. So we're going to have a unit of measurement to the third power. And we could write 1,000 feet cubed, or we could write cubic feet. Here we are given the area of one face of a cube, and we want to find the volume. So it is important to realize that area of a square, right? Each of the faces of a cube are a square. The area of a square is just the side length squared. So in order to figure out how to find the volume, we need to figure out how to find a side length. And now we just need to think of what 2 numbers can we multiply together that give us 16. And the numbers that fit this, of course, would be 4, right? 4. And side lengths are in centimeters, right? So 4 centimeters. And this side length here is going to be 4 centimeters. And since all of the side lengths are going to be equal, we know that all of these are 4 centimeters. And now to find the volume of this cube, we can just take the side length and multiply it by itself 3 times, or cube it, right? So that's going to be 16 times 4, which is 64. And we are talking in 3 dimensions, so this is going to be centimeters to the third power, or cubic centimeters, and this is our answer. Now we want to find the volume of this cube when one of its face values is 25 units squared. And to find one of the side lengths, which is what we need to find the volume, which is what we are trying to do, we need to take the square root, or just figure out what number multiplies by itself to get to 25. And of course that is 5. So the side lengths here are 5, 5, and this side length here, and I'll draw it out. This side length here is 5. This is 5. And to find the volume, we're going to take 5 units and then raise this to the third power. And then we can distribute this exponent here, right? So 5 to the third power is the same thing as 25 times 5, which is 125. And then units cubed or cubic units, and I'll just write units cubed. So this is our answer. The volume is 125 cubic units. So now we are given the volume of this cube and we want to find the area of one of its faces. So we know that the formula for volume is a side length to the third power. So we know that the side length is going to be the cube root, or just a number that multiplies by itself 2 times, right, to get 64. And we can just test this out. So 2 to the third power is 8, 3 to the third power is 27, and we know that 4 to the third power is 64. So this means that each of these side lengths, and I'll write here, each of these side lengths are going to be equal to 4. And I'll just write these two side lengths here, and I'll make it clear which ones I'm talking about. And now we want to find the area of one face, and the face of a cube is just a square, right? So we are going to multiply 4 by 4 to get the area of one face, and that is going to be 16 meters to the second power, or square meters, and we are done.